Hi everyone, Sudipto here. Great to have you with us. Get ready for an exciting hands-on project using logistic regression in Knime. In this session, we will tackle a real-world scenario predicting whether a user will click on an online advertisement based on their demographic and behavioral characteristics. We will walk you through the entire process from data preparation and model building to evaluation, all using the powerful Knime analytics platform. Let's dive in and get started. The dataset is imported using the Excel reader node. Upon execution, the dataset becomes visible. It includes data types, integer, float, and string. The columns present here are daily time spent on site, age, area income, daily internet usage, ad topic line, city, mail, country, timestamp, clicked on ad, etc. Among these, the target column or dependent variable is clicked on ad. Next, we will execute the column filter. The column filter node is applied to remove irrelevant features that could negatively affect the model's prediction accuracy. Therefore, we eliminate string and time related columns like timestamp city. Here we can see that we are excluding time and country, city, and at topic line is also removed because it has not impact on the dependent variable. Next, we have executed a pie chart that we can see the zero number of variables is more than the one number of variables. So after this, we can execute a histogram where a age-wise plot has been seen. In this plot, we are seeing that the frequency of 103 is from 37.90 to 40, which depicts the highest amount of one number of variable. Next, we will execute the number to string. The number to string are values are the data type of the target variable is changed from number to string. This step is essential for performing logistic regression. The values of 0 and 1 are converted into string data, and then we will execute the missing values, and before that we will execute a bar chart. In the bar chart, we can see that the age-wise distribution has been sent where the at click section has been shown. In the next portion, we can see about the missing values. In the missing values portion are normally for numeric variables. If missing values exceed 10 to 15% of the data set, we replace them with median values. However, since very few values are missing here, we are simply removing rows. We can see and execute that. We are doing remove rows here. And upon executing this, we can remove the values that are not there and remove the rows that are not there actually. Then we will use the normalizer. The normalizer is there to normalize the values. We proceed normalizer node to normalize variable that shown the variation. Columns normalized include daily time spent, age, area income, daily internet usage. These variables might contain outliers. Even if they don't, the normalizers ensures better model performance. After executions, the values are scaled, making them ideal for model training. We can see here the values are scaled between 1 and 0 if we execute this. Next, the table partitioner node is used to split the data into training and testing. And upon execution, we can see we choose 70% of the data for training and opt for random sampling. We didn't do the stratified sampling here because it's a medium-sized data set, and stratified sampling is necessary here. Then we do SMART. SMART, which is known as synthetic minority oversampling techniques, is applied because there are more zeros than ones in the target column. To balance the class distribution, ideally 50-50, we use SMART to oversample the minority class. The target column is clicked on at, and the nearest neighbor is 5. And after this step, the training data is ready. And we have executed 4 models: logistic regression, decision tree, random forest, and naive-bayes model. We will not run the SVM model since it holds no significance for binary classification and is more applicable for multi-class classification. Similarly, the R-prompt MLP model is more aligned with deep learning and suited for complex conditions, so it will not be executed. Finally, the next models will be discussed by my fellow mates.
We are using the logistic regression model as it is well suited for binary classification problems. However, we have observed that its performance is, is slightly lower compared to some other models. Therefore, we plan to explore additional models later to improve the results. Looking at the confusion matrix, we can see that the true positive and true negative values are significantly higher then the false positive and false negative values, which indicates a good model performance. The model's accuracy stands at 0.97, meaning that during testing, 97% of the predictions matched the actual outputs, highlighting the model's reliability. Furthermore, the ROC curve shows that the prediction score is close to 1, especially around 0.996, suggesting strong predictive power and high accuracy of the model. Now, I would like to call Shubhendu to continue with the presentation.
Now we will look at the decision tree model. Here the accuracy is 0.947, which is relatively lesser than other model, but it also has a quite high accuracy, and ROC curve is also depicting the good performance of the model as the previous one. The discussion will now be taken over by Sayantoni Ghosh.
Random forest is the best model here because it is the model where SVM logistic regression, decision tree, k-means, k-nearest neighbor, Knime bias, all the models are included. Random forest is a tree under which all the models are there. Including all this model, a general model is created as random forest. So, not only for logistic regression but also for any other purpose, random forest is the best. If we execute this in the confusion matrix, we can see true positive and true negative value are quite higher than false positive and false negative value, which is good for the model. Now, if we check accuracy, we can see it is 0.97. It means where we execute the model in training data, whatever the output is there for any input, in testing the percentage is 97. It significantly proves the model perfection or accuracy. If we see the ROC curve here, the prediction at 1 is very good. It is towards 1, that is 0.991, which proves the accuracy and futuristic character of the model. So, the video will continue by Sanjay Das.
Now we will be the Mba-Bads model. It is in the conclusion matrix, the same condition is seen as previous ones. If we see the accuracy, it is 0.973, which is quite high also. And the ROC curve is depicting the relevance and perfection of this model. The discussion will now be taken over by Sudipto Roy.
So the logistic regression model performs with high accuracy because the dataset contains no outliers or the missing values. Therefore, logistic regression is so utilized within the random forest, and it is observed that the accuracy of both models is close. As the random forest model includes the logistic regression model and the weightage of logistic regression is the highest, more than 90%. Apart from logistic regression, the other models also have influence on random forest. Even though the naive-based model shows high accuracy, we will choose logistic regression as it suits a binary problem base. Additionally, we will consider the random forest model because it is overgeneralized and encompasses the other models as well. Hence, we recommend logistic regression and random forest models. The other models were executed just for showing purpose. Now, I will request Priyanka to conclude the video.
Now we will combine the scorer from the different models using the concatenate nodes. To do this, we have already connected the output from the scorer nodes. Finally, we use the Excel writer node to export all the result into a single worksheet. Once execute, the consolidated result will be available in a spreadsheet where we can view and compare the performance metric of all the models. With this, we conclude our project. Thank you for staying with us till the end. We appreciate you watching. Thank you so much.